You already know who I am, but maybe a little bit about what I do. So I work a lot with our mining organisations to ensure that business and technology meet in effective ways to actually get good outcomes for business, right? And I work in that industry, work with partners, work with clients to actually help them understand where technology is going and how they can help them, but more importantly, listening to those clients and then figuring out how we can deliver things to the mining industry more broadly to actually help optimise their business and increase their performance. Today, we'll actually be talking, as I said, about digital twins and simulation, both what's happening now and what's happening in the future. We'll talk a little bit about how we visualize some of those things using spatial computing, which for anyone that doesn't know is Apple's VR platform that we use. And we'll talk a little bit about the platforms that underpin that and deliver some of that capability. Today I'm joined by John Cass from Whitehaven and Tim West from DXC, and I'll throw it to the two of you to introduce yourself. So John, maybe over to you first.
Yeah, thanks for having me, Paul. So I'm John Cass. I'm the Operational Technology Manager for Whitehaven Coal. Very proud to be here today as part of the 2025 IMARC, so thanks for having me, and I'm pretty excited to be discussing some of these future prospects that we have when we look at continued digital evolution and the advancement of the digital twins that we have today. So my background, I'm an auto electrician by trade. I grew up on 555 timers and electric circuit boards, but I'm really passionate about people using technology to enhance operational safety, productivity and efficiency. So yeah, thanks for having me.
Thanks, mate. Tim, over to you.
And yeah, so Tim West, and thanks for inviting me along, Paul, and good to see everybody. Really excited as well to be here. I'm the Global Director for Product Development at DXC, particularly looking at applications, data, the embedded software engineering that goes into the cars and the like of that. And of course AI, because we can't go too far without saying those words, and we got that in the first few sentences.
Very good, thank you. So maybe some foundation setting. We're going to talk a little bit, as I said, about what digital twins are doing. So maybe over to you, Don, to think about what's important in mining right now and why are digital twins the things that are helping you improve operational performance?
Yeah, well, I guess, digital twins it's almost becoming foundational for our mining and processing operations. It's interesting. We had a chat earlier in the week about this, and then when we wander around the stands, there is just so many digital twins out there at the moment. But it actually starts from the mining concept. What resource is actually there? How do we process that resource? How do we get a business case up to start off with? And that digital twinning model is fairly, it's pretty basic actually, to tell you the truth. But when we look at what resources are there, what's the value, how can we extract it? There's actually, it's extremely complicated from a mathematical point of view, but from a digital visualization, actually understanding what is the best asset, that then continues to advance through multiple tool sets. So I guess it starts with the modelling of the resource and the extraction. We also see a lot of digital twin modelling around our processing of the resources. How do we actually extract as much value as we can to make sure that the product is on spec, but only on spec, because you can lose a lot of value either way there. Our mine planning team do a significant amount of digital twin modelling when we look at haul strings. Do we have the right capacity to actually run those circuits on that day? Are our haul strings too long? Are we constrained by haulage? We're constrained by excavation. So there's a continual modelling of that back and forth. And I think the real exciting part is how do we start to combine some of these models together?
Looking maybe a bit over the radar, are you experimenting with anything now for what you think is coming?
Yeah, so probably the experimentation part for us really comes on visualization. How do we sell that story to others to show them what the mine's going to look like, what the final landform is going to look like when we put mines into closure. So I think the power in visualization and storytelling of digital twins has only just begun.
Yeah, I think that's one of the things where spatial computing is so powerful in that, right? Which is why I'm really keen on how we do the visualization for those things across these digital estates that we're creating. So maybe, Tim, same question for you. You work in a lot of industries very broadly, globally. So what do you think is happening and important in some of these adjacent industries to mining? And can any of those things that are being used for digital twins there be applied back to the mining industry?
Yeah, certainly can. I think you can look at any of the kind of asset-intensive type industries, so travel, transportation, manufacturing, defense, those sorts of industries are all looking at and creating and evolving digital twins for various different use cases. So I think that we can sort of take some of the use cases we're starting to see emerging there. One is just visibility from a distance and remotely for something. So for example, a rail operator we've worked with, we've actually been able to create a recreation, a section of the line that they're looking at. How do we actually maintain and upgrade that section of the line to increase capacity? How do we effectively make the right decisions on these really large, tens of millions of dollars worth of investment when we can't get the board there to actually go and see it? But experiencing it, in this case using virtual reality or spatial computing of one form or another, really helps people understand the decisions that they're making and the gravity of them. That then quite nicely goes through into safety and training, right? So actually feeling like you're there is so much more important than and meaningful than reading the manual, right? So we've worked with explosive manufacturers where you really don't want to train people for the first time properly with real explosives, but you want to make them feel like they're actually really there so that the training and the muscle memory embeds. Another good example of that is, for example, with airline pilots. Right? Airline pilots need to get certified in order to fly, the Boeing or Airbus airliners. Those simulators cost tens of millions of dollars, and you just can't get enough pilots through them. But using spatial computing, we can recreate the cockpit, allows them to build the muscle memory of literally reaching for the buttons, thereby embedding that, meaning they spend less time in the simulators to actually get certified. And then likewise, complex support activities. You may, a good example in mining would be, you've got different types of dumpers and you've got different types of machinery, right, that you're having to maintain. You may not have seen that one before, or the last time you went through the how do I maintain this was, months and months ago. But we can actually now augment and put those training materials in and alongside you. We're seeing that with jet engine maintenance is massively increasing the quality of maintenance, while at the same time actually reducing the amount of time it takes to train to maintain a really critical piece of infrastructure, in this case a jet engine, to keep a plane in the air, right? So it literally takes like a tenth of the time to certify those people and get them up and running because we're augmenting them in the process.
Yeah. That's 2 minutes that you talked without mentioning AI. So I think, though, the interesting thing for me is, as we move into the AI world that's happening at the moment, right? Agentic AI is the big thing that everybody's doing. How do we create action in work that's happening? So I think there's that visualization of what AI is going to be doing to actually give you oversight of that in your digital estate that you're creating, that I think is a really another important use case for all of that. And so, John, with you, do you think the use of AI and what's over the horizon with digital twins is going to be increasing in mining over time?
I mean, AI's here. AI's great for anomaly detection at this point. It's not so great for being creative reliably when you need to create with any sort of precision. So that will come in time, no doubt. But I think at the moment, when we think about using AI and digital twins, it's really good for the huge, large-scale calculations or anomaly detection. So when we think about a digital twin that is actually streaming us our data as it's received in the field with an AI layer over it, it actually, probably the biggest advantage there is increasing the support that can be provided to the frontline workers through an augmented environment of some description. So I think that AI, maybe not so much on the creating front, but definitely in the helping perceive and identify, what do I need to be looking at now? What's going wrong? What might be going on next? Where are our big value areas of the operation?
Have you got an example where you've tried to do that?
Anomaly detection. I think there's a lot of anomaly detection going on out there, especially when it comes to fixed plant sensors at the moment. We see a lot of fixed plant sensors with high data processing, so that's definitely one there. There's also, we're starting to try and identify areas of interaction between different pieces of equipment. And probably the next part where Whitehaven's really interested is trying to spread that anomaly detection across our mobile assets.
I think that also tends to go into the world of simulation that we've been talking about recently as well, right? So are you seeing the increasing use of simulation to validate decisions prior to actually action being taken in your business? And even looking at AI, when we're actually using this to visualize those things now, is simulation being used as the guide to actually direct AI in the direction that you think is most appropriate for the outcomes you're looking for?
Yeah, I guess the great part of any simulation is it's only a simulation, right? And we do all this desktop simulation, but unless you actually validate it and check how that's performing in that field, use that information to tune your model, you could end up going down a garden path because you've got a few basic parameters that are offset in your calculations, right? So it's always important to come back and validate that in the field and say, is that actually, we predicted that we would need 12 haul trucks on that circuit for the last, 6 shifts. How many do we actually need? And then, okay, well, why did we need that? What was the difference compared to the predicted model? I think that's going to come in all forms for a long time. It doesn't matter if it's, how long is it going to take us to change that engine in that excavator, possibly. That's a large shutdown job. That's high value. And, AI could say, well, it's this failure. It should take that long. Really, the other part of all this digital twinning is how long is that going to take when the technicians on the machine are actually connected to engineers in the back of the office with all of the schematics, with all of their process plans, and all the Gantt charts, knowing exactly what is the next step and who needs to be where. That's where we're going to see some huge productivity improvements in how efficient we are at undertaking some of the maintenance operations.
And do you actually see the trend in your business and in your cohort moving in that direction quickly? Or is this one of the things, like I've seen a bit of a slow adoption of these things, right? It's been that very slow and steady encroachment of it. Is there anything that is pushing it forward where you might think you want to get there faster?
Yeah, that's a really interesting one. In-field connectivity, right? So in-field connectivity from technicians is actually led by some of our contractors that started rocking up with their Starlink units on their utes, right? So they can be connected to their engineers in the office. So they actually led the charge on that. I think miners, as an industry, we're generally a bit slow to adopt a lot of this technology. We've got, we can see the advantages, but we continually, we've got budget cycles that we need to put into. We want to make sure that we validate what is out there, because we understand when we make a decision, it a lot of the time turns into a long-term decision. So if we select the wrong technology platform to do that on, it can be very hard to change away and go to the next thing. So I think that's where miners probably need to embrace a bit more of the change and go with the flow, right? Like, don't get too deeply invested that you can't back out and switch and go in a different direction, because technology is changing that quickly. We need to have some versatility. So we need to get the foundations right, and those foundations start at where we receive our data from, what are those data sources, how accurate is that data, but also if we talk about building a digital twin and combining the multiple layers that are out there from the logical views of how is the material moving from the business design down to a builder's level or a tradesman's level, or what are the actual components in there, and I'll go into it. I don't know if Paul wanted me to, but there's a model out there, right? It's called a SABSA model, and it's actually for cybersecurity. But it basically talks about 5 different viewpoints of the world. So we've got a business view that gives us, what is the purpose of this asset? We've got a builder's view. How does that come together? We've got an architect's view. What are the actual parameters, the design of this area? through to a tradesman's view and technician's view. When we think about our digital twins, they're often only solving one or two of those viewpoints. When we think about where a digital twin is going to be, where we want it to be in the next 10 years, we actually want at least 4 of those viewpoints to be in the one twin model. And that's the challenge, is how do we bring all those different viewpoints into one plane, maybe not to compute it, but for people to interact and perceive it.
So these are cyber-physical models that you love so much. Are you thinking about adopting those kind of things at Whitehaven? Because it does feel like there's a lot more detail in the implementation for the things that you're talking about, right? Whereas people at the moment are implementing what is my greatest need right now, as opposed to thinking about the depth that you're talking about.
Yeah, I think that's probably me being a bit of a tech dreamer, right? Like, you need to understand these models and where we're going far in advance. So the cyber-physical twin is a really interesting concept, right? So how do we bring in our digital twins and actually include SCADA elements in that, where I interact with my virtual environment and it actually turns on an actuator in the field, right? So that is one step to say, well, how do we let people do their job and be immersed in that environment from anywhere in the world? And that applies to how do we do remote operation centre conduct remote operation centres with this new capacity. A previous presentation, we were talking about 4K, 8K video streams off bulldozers, right? How do we bring that back to a centralised location? How do we use that to assist with our training of the people in the environment that they're going to encounter? And if we take it a little bit further and make it a little bit more fluffy, how do we use all of this information to train the humanoid robots that are going to be with us in another 10 years' time, right? So we need these models to start training the robotics to complete the tasks that they haven't encountered yet. Even in 10 years' time, when all this comes to fruition and we start to see a few of these humanoid robots in the field, if we don't have a solid digital environment to be able to control and interact with those robots, they're going to get stuck. They're going to get stuck in the field. We might need to take control, but how do we take control of that and teach the robotics at the same time how to overcome that situation? How do we do that efficiently?
Yeah, I also think digital twins are kind of fundamental. Like, the whole instantiation of the cyber ones where when you push the big red button digitally, it pushes the big red button in the real world. That's key for introduction of real agentic AI on your business as well, right? So if you actually want to hand over control to small elements of your business, you need to be able to have that degree of control in your digital twins. But coming back to simulation that we were talking about, like, what trends are you seeing, Tim, more broadly out there in industry? And again, with reference to, does that apply to mining, and where can we do that?
Yeah, look, I think we're starting to recognise that while digital twins look cool, right, that tends to be where we started. I think it's sort of what you're talking about there, John, was that, yes, we want to be able to visualise and see, but if we want to be able to actually take action as a result and one day have the AIs take action for us, then we actually have to, first of all, build a proper digital footprint and twin of the business, not just being able to see it and see the mine, in 3D or whatever, but it actually has to then define each of the assets in software so that we're able to orchestrate action. And only once we can orchestrate action can we actually start to bring AIs into play effectively. Be that on a mine site or indeed in any other industry. I think most industries are starting to go, the reason AI beyond the sort of white collar workers isn't being particularly effective is because we actually haven't built the digital models of the business that we're doing, and then where we do, we've often just really made it a visualization type approach, which looks good and it plays well to boards, but doesn't actually help us achieve real difference. And so that's where we need to start modeling this as a software. You're a techo nerd. You can think of it as software object modeling, right?
Yeah, I think the AI take on it is You know, like we see these systems, we see the simulations. The simulations are normally either, you know, physical or mathematical, but it's very rare that we can combine the two in a element that provides context. When we start to bring in more and more AI into that to validate what's happening in the field or identify the variances, the key part is the feedback model, right? And it doesn't matter if you're doing a builder's view or conceptual view of how that design's actually going to work, unless we do the simple plan, do, check, act process and feed that back into the model to say, hey, yes, you were correct, that was an anomaly, that did cause downtime, or yeah, that was a good move, you know, or it didn't for X, Y, Z. That's the key to actually getting AI to move forward.
And I think you touched on it briefly as well. We're talking about some fairly advanced concepts in things, right? How do we get digital twins working things? How do we get agentic AI working? And you with your humanoid robots, like as the next evolution for those things, which makes sense. You instantiate the AI in a humanoid robot. But there's a whole lot of foundational tech that is necessary to do some of these things. So are businesses ready to do some of this stuff? And what is some of the foundations that you think are necessary to achieve some of these things or to get on the path for some of these things?
Yeah, it starts with the really boring stuff that's actually really hard to do, right? Like the sensors. I've got one customer we were talking to about how they've got SCADA controllers, and we want to try and get the stream from the SCADA controller and match it up into the software-defined version of their business. And it's like, yeah, the problem is the SCADA controller actually runs on a 486, which was, I actually built a 486 as my first PC back in the 90s.
Both of you with your
Probably
hardcore
both, maybe,
tech in the
right?
basement.
And it's like, yeah, crap. So how do you actually maintain that at the moment? We buy 486s off eBay, right? Literally. And they're running pretty big infrastructure on this stuff, right? Well, we can't actually get that to stream out the sensor data. It's literally just used to do the control. So we have to look at some really basic, okay, how do we get that sensor data? How do we get that streaming through? How do we then line up all the different pieces of data across the business so that we know that that sensor is on that dumper or on that train or on that airplane or whatever it is, so that we know that asset is this asset in their SAP asset management system, so we know when it was last maintained, so we can start to make decisions now that we've started to line those things up. So just getting all of that data streamed through, getting it so that it's interoperable. No matter where it is, you know that those things are in place. Then we can start to get to the more fun stuff. It's actually the really basic engineering that just needs to be done first.
Yeah, I think once the pursuit is undertaken, there is foundational updates, upgrades that you need to do. You need to have a look at the technology in your operations in the field and say, is this capable of doing what we need it to do? So I think you have foundational updates, but the first part is, what are the problems that we're trying to solve, right? Where is the biggest problems that we can use as a roadmap or a launch point to continue to embrace these technology and these platforms? So I think identifying those business cases, for us it's really been about communicating stories to stakeholders, to investors and also regulators. Right? What is the story we're trying to tell? What does that design look like in the field? So when you understand those launch points and you consolidate on that, then you can continue to build as a process of evolution. And now I think long term, there's actually organisational change that needs to occur as we move people from the people executing a process to the people overviewing a process. You know, the people still need to do the plan, do, check, act. Is this correct? Is there additional opportunities for improvement here? I think it's going to be a long time till we see systems really suggest organisational change to us of how activities are undertaken in the field.
We're going to need the human in the loop for decades.
Are we just telling ourselves that because we don't want to be made redundant?
Oh no, I'm quite
can
happy
take
to
my
go
job.
sit on the beach and drink the pina colada. So no, I'm bring it on. I just don't think we're at the point where we can rely on the AIs to make those decisions. We can get them to help recommend and suggest things to us, and then we need to oversee it and say yes, that is the right course of action. Please proceed. I mean, presumably you also need to be able to observe it as it undertakes some of those actions in your remote operation centres, for example, to make sure that it stays on task and doesn't move off. We're quite a long way off being able to take the human out there, I suspect.
No, look, I agree, right? But I think it is moving so fast, and you think, generative pre-trained transformers when you were born in 2018 out of a Google lab, and look how far it's come in the last few years, right? So I think it's just accelerating. There's this exponential growth that we're actually seeing in that area. But coming back to, you just touched on remote operations. Where do you think, John, and I know we've talked about remote operations, spatial computing and some of those things in the past, right? But what do you think about the future of remote operations? In my mind, I go to defending the gate at Zion in the Matrix for what it could ultimately be like. Do you think it's going to be that mad, or it's going to be something pared back a little bit? Where do you think it's going?
I think remote operations in I don't know, 20 years' time, who knows where that's going to take us. Really, remote operations, a lot of remote operations, what's the point of it? What do we get out of it, right? So we reduce some travel expenses, we reduce some accommodation expenses, but the true value that we get out of remote operations is centralisation of talent and sharing of skills and knowledge between those different workers of the same group. When we take that to an augmented reality, those specialists could be anywhere in the world and could be in a completely different calibre. So if we were to step outside of mining for a bit and we go to the surgery, right? You need surgery. Perhaps you've had a heart attack, you need a valve replacement, or you've broken your foot, or you've broken your leg, some exquisite injury, right? When you can connect specialists from anywhere in the world and effectively plug them into that environment so they can see what's going on, that's one of the true remote operations centres. So it's the ability to connect talent from anywhere in the world to solve your problems. And it doesn't matter if those problems are a machine's broken down, I've got a hydraulic failure, right? And it's, a Komatsu PC4000, it's got an extremely complicated, hydraulic system that quite often fails. But when you get the people that understand those systems back to front and have faced those challenges a few times, they're all over it, right? So if you develop your pockets of specialists in different machinery, different processes, different operations, and can connect them into your virtual environment and collaborate with them, that's really the big win that I think is going to come out of this augmented reality world.
I think a good example of that is actually in the healthcare sector, right? Imagine the Royal Flying Doctors landing in to a car accident in the middle of the Pilbara somewhere, hundreds of kilometres from the nearest habitation. There's no way they can land every specialist there, but they can have every specialist on their shoulder ready to help them with whatever it is that they see there. And we're making that data available through digital twins and the connectivity of Starlink and so on today, right?
Well, even bring that back a couple of steps, right? How is it when we have maybe we've got a geotech failure, we've had a wall fail, and we need to come out with a different solution to dig it in a safer manner, or we've seen some cracking start to develop on a wall. How do we assess that quickly? By being able to collaborate with those stakeholders, those specialists, quicker, faster, and gives us a better outcome. That's that is your safety, your efficiency, and your productivity benefits.
And I know that we talked a bit about spatial computing during all of this, and we used that to, as our VR platform for a lot of the things that we do, because that's sort of our bent. But that platform actually extends to other devices as well and other things that we use, right? So Tim, what are you seeing where, that sort of platform enablement using some of those things is applying to other customers in these areas?
Well, I think the best way to think about this is as we move to that cyber-physical world, to use the steal John's term there, you actually need a really tight integration between the hardware and the software. I mean, how do you run an AI model locally that's trained to do something in particular on that device, right? That requires a lot of that thinking, but there's much simpler use cases. For example, we work with a utilities distributor, and they are able to, when they're maintaining power lines, they've got Apple Watches on all of the individuals, so they can now push an alert saying, hey, look, thunderstorm incoming, get off the bloody power line so you don't get struck by lightning, right? So they can push alerts, so that's a really simple use case, but we also then are able to monitor the health of that worker. So we're literally able to realise at a biological level that was a hard piece of maintenance for them. Maybe it was hot that day, for example. So we can change their brake pattern and go, no, let's bring their brake forward. Or conversely, that's actually physically been much easier than we expected, so we can get another job in before giving the brake, right? So we're actually able to get much better insight and data into the whole planning process right across the piece. Another example is with a police force. When they get into the car, the policeman actually puts the phone on, and it flicks the phone over into the Apple CarPlay, right? And now it gives them the apps that they need for that task in the car, driving the car in the pursuit, and turns off all of the other things. So we're able, when we've got that really tight coupling between hardware and software, to be able to develop across multiple devices, really get contextual data to people and into the business process as well.
In the 2 minutes that we've got left, any final thoughts? Because I think this is an awesome topic, right? An awesome area where interesting things are happening. So
I don't know. Just sitting back, I'm thinking a lot of this stuff. We've seen a lot of cool tech done, used by NASA and SpaceX and these other companies that are doing simulations to mine asteroids and send satellites around the world, and really long-term things. But then they can also consolidate and pull in the right resources when something goes wrong, when something needs to be fixed, and sometimes that stuff can be archaic, but they get it done, and they can simulate what is the required fix because they have the models there already. So a lot of this stuff, when we talk about digital twins, it's already out there. It's already sort of been done, but it's been done in 10 different platforms from 20 different viewpoints. We talked about sitting in the car, plugging your phone in, and having your apps come up and all the rest of it. How do we digitize all of that so we're bringing in the real life field inputs, but then we've got a digital platform to complete these features which are happening out in the field today. So I think there's a lot of work to be done, but really start off, define what is the business case for this, what are the problems that exist in our business today, and then how can we fix it with a long viewpoint to actually consolidate all of these digital twins that already exist.
Well, thank you very much, John and Tim, for your time today. I've enjoyed the conversation. Thank you all for coming along and listening. Don't forget to come to DXC's booth. We've got a demonstration on spatial computing using an open cut mine where you can actually play around it and have a look. We also have one for a training exercise where we've done the explosives truck that Tim mentioned. Also, don't forget the great merch that you can actually come and get at our booth. And also there's the prize that we're doing for the Apple Watch Ultra, so please get on board for that. Thanks very much for your time, guys.
Thank you.
Thank you.